Okay, so I have a Dell monitor that when you plug it in, the power light just sits there and blinks. So we're going to take it apart, see what we find, and fix it. Okay, first thing we want to do is take this stand off. Push that button down there. It comes right up and off. Look inside there, we got 4 screws. Now sometimes with TVs or monitors, you'll have screws or the video, the VGA will have some, its standoffs will be in the case, but in this one there's nothing, so those 4 screws are it. Time to pop off the case. Okay, so to get the case off, if you look real close down here, there are a few places you can see a place to stick a flathead screwdriver. Oh, look at that. Pop that up. Pop that up. And pop that up. So the bottom is pretty much the only place that you have anywhere to do that. Just keep and at this point it's just time to start pulling. Alright, so once you get it up, you will have the power and other control buttons on the front still connected. So let's go ahead and get the monitor out of there. Lean it forward and the monitor will kind of fall out. Need to assist it a little bit so then the back case comes off. Alright, so now, so I want to get inside the monitor. There's 2 screws on one side for this metal shield, and there's another 2 screws on the other side. Right there and there. I'm going to take those off. Just going to have to slip it out of that front cover. We can go ahead and take that front cover off with the control buttons. Let's tape it on there. Okay, the side screws are off and everything lifts up. So this will expose all the electronics to the monitor, and when you go to take this off, there's some more ribbon cable holding it on to the screen itself. And here it is. Alright, so there's some sticky stuff holding it to the screen. Go ahead and pull that up, and you'll have this ribbon cable. All you need to do Just squeeze these two things together, it unlatches it, and then you pull it off. And then you got ribbon cable off of the screen. And you also have your wires that power up the backlight to the screen still attached. Those are pretty common, so just you can leave these attached, just undo the tape. We'll tape it back up when we're done. That way we can lay the electronics out flat and still see everything that's in there. Alright. Everything is exposed now. So first thing we want to look at when it just doesn't want to power up at all is the power supply. So let's take it apart and look at the power supply. Just 4 screws, it looks like, holding this on. Nope, there's 5. A video to the monitor. So that part, let's see, is got some wires running there. They're not disconnectable from this end, but let's just take that board off also. Down there you'll see, gotta take these off. Okay, everything's off, so let's see if we can get it lifted up now and look at what's underneath. So the video card's out. It has a plug. Disconnect it from the power supply. Power supply's got the 120 volts going in. Just unplug it. And then you have the power going to the backlight. So this inverter here, disconnect it. So these plugs have a little hook. You just have to push on inside. Get that hook to push on the bottom. Opens the latch and push it off. Unlatched. Now unplug it. It's not easy. It's unlatched, so now gotta get a screwdriver in there to unplug it. It does not want to come out of there. Alright, they're out. Both of them. Got the latches. Okay, it's unlatched. Unlatched. Get the screwdriver in there. Pop it out. Pop it out. No, that one latched itself back up. Now I'll pull that one. Okay. Okay, so we have the power supply out. The first thing you want to do is do a visual look over, see if anything looks burnt or just out of the ordinary. And something that caught my eye right away was these 2 capacitors. If you look, they're not flat. They're bulging at the top, and they should be flat at the top, like these 3. But right there you can see the tops are not flat. They've been pushed up and they're bulging. And only 2 things can cause that. Either they have a high reverse voltage that would cause it to bulge, or there's something internally wrong with them. And in this case, I believe there's probably something internally wrong, and we're going to go ahead and replace those. Then the other thing I found was this little capacitor here that's on the high voltage inverter circuit for the back display is black. A capacitor should never be emitting heat, so it should never get hot to the point that it turns black. The only way it can get hot is if there's an internal short, or if something next to it is really hot, and in this case nothing around it you can see has been getting hot, but that capacitor right there has definitely been getting hot, so I'm going to need to replace that also. It has gotten so hot to the point that I cannot read the markings on it. I can just go by, you know, these two capacitors to find out what the value is of these two capacitors. Alright, so I got my replacement parts. The markings on the bad ceramic capacitor here was U2 15J 3kV, which stands for, I believe the U2 stands for the dielectric. The 15J stands for 15 picofarad, and then the J is the tolerance, which in this case is 5%. And then the 3kV stands for 3 kilovolts. So the replacement capacitor I got was a 15 picofarad, 5%, with 3,150 volts, which is 3.15 kilovolts, which as long as you have the farad the same and the tolerance percentage the same, your voltage can be either the same or more, and you're okay. And then I got the two new electrolytic capacitors to replace these, and these two capacitors are both 680 microfarad, 16 volt, and then the new ones I got are 680 microfarad, 25 volt, and once again, you want to make sure you have the same farad going in that is coming out, and then the voltage rating has to be either the same or more. So this one's more, and now we're ready to remove the old and put in the new. Alright, so if you want some tips on unsoldering, or if you just would like to see how I do it, what I do is I'm going to blob some fresh solder onto the old solder leads. That way the heat is for sure to flow on there. Now, when doing soldering, you want to make sure you're wearing safety glasses, because solder can splatter up in your eye. Alright, so I got some good blobs there. Now I got a solder sucker. So big old long plunger type deal that it has a spring action sucking action. So just suck the solder right out of there. Okay, and that just fell right out, but I'm still gonna clean that connection. There are different versions of the solder sucker. I just prefer this one, seems to work the best. And then clean up any excess solder balls that are left over from removing the component. Alright, so both of them are removed. Now let's just do the same thing for the ceramic capacitor. That one's right here. Blob some fresh solder on there. Help transfer the heat to the leads. And suck it out. One of your leads still may be just lightly tacked onto the wall or something of the, there it goes. Pretty simple. Alright, so as far as installing the new capacitors in, you want to look at the markings on the where the old ones came out, and hopefully whatever you're working on has these markings, but this white half with the white dot indicates the negative side, and on the capacitor itself that you're putting in, this dash right here indicates the negative side of the capacitor. And also, if you look at the leads, one is longer, one is shorter, and the shorter lead also indicates the negative side. So just want to make sure you put the negative side on the correct side, or else you'll have the potential of blowing up the electrolytic capacitor. So we'll just push those down there flush, and then just on the bottom spread the leads out a little bit to hold it in there. So they're hanging in there. Now you can put some flux on the solder connections, but I got some solder that has the rosin flux in it already, so I don't need to do that. But some solder does not come with it, and then you have to put some rosin flux on there. And it's that simple. Opposite side, everything looks good. Everything looks good there, so we'll go ahead and cut the leads. You just cut them right at the top of the solder mound there. Alright, so our first two components are installed, and now it's time for the final one. And now we're down to the burnt up ceramic capacitor. And when installing this, you do not need to worry about the polarity. It doesn't have any negative or positive. Ceramic capacitors are not polarity sensitive. Here's my new capacitor, and it does look different, but that's fine. It's the same thing. So with these, you want to be careful with how you handle them, and you don't want to be bending the leads much near the base of the capacitor. You want to make sure they don't get bent at the base of the capacitor, because you run the risk of cracking it. So I just have it stand up a little bit, and then I bent the leads out underneath to hold it in place when I flip it over. So now this one is ready to solder. And that's it. Make sure everything looks okay on the other end. And yeah, it's up off the board a little bit, just like the others. So now let's just cut it off. At the base of the solder mound, at the tip of the solder mound I mean. And let's put everything back together and try it. Alright, since we were soldering on this, we need to make sure we clean up our solder joints with just some alcohol and a Q-tip. Get that rosin flux off of there, because that flux is acidic, and this power supply is going to be getting hot and cold, and the heat from the power supply will activate that acid in the flux, causing it to corrode your solder connections and any of the traces in on the circuit board. So just want to make sure you clean up the flux off the solder joints so we don't have that problem. And also it'll stink for a long time if you don't clean it up and it's constantly getting hot. And alright, so I have it all back together. Let's see what happens. Bingo. Looking good. Alright, so we fixed our Dell monitor.